Good morning, my dear students. In next class, we will deal some problems based upon the heat exchanger. Some problems based upon the heat exchanger. So, how to solve some problems based upon the heat exchanger? Before that, you have to remember some formulas. Okay, now before that, you have to remember the some formulas. Based upon that formulas only, you have to solve the problem. So here, as you can see here, some problems are given. So first one is the first I wrote the formulas at one place. So what is given here? First one, Q. Q stand for heat transfer. Q stand for heat transfer. The formula is MHCpH TH1 minus TH2. So here Q is equal to MHCpH TH1 minus TH2. TH1 is stand for hot fluid entry and TH2 is stand for hot fluid exit. This one for entry and this one for exit, and CpH is stand for specific heat for the hot fluid, and MH is stand for mass of hot fluid. Next one, you have to remember this formula. What is the formula? Heat lost by the hot body is equal to heat gain by the cool body. Heat lost by the hot body is equal to heat gain by the cool body. So MH CpH TH1 minus TH2 is equal to MC CpC Tc2 minus Tc1. MC CpC Tc2 minus Tc1. So heat lost by the hot body is equal to heat gain by the cool body. This is the second formula. Next one, LMTD for parallel flow. LMTD for parallel flow. Parallel flow. Here theta, LMTD stand for logarithm mean temperature difference. Logarithm mean temperature difference. So theta m is equal to theta 1 minus theta 2 by in of theta 1 by theta 2. So here you can write theta 1. Theta 1 means Th1 minus Tc1 and theta 2 means Th2 minus Tc2. Now LMTD for contour flow. LMTD for contour flow. Same formula is there, theta 1 minus theta 2 in of theta 1 by theta 2. But here theta 1 can be write as Th1 minus Tc2 and theta 2 can be write as Th2 minus Tc1. This is theta 1 and this one is theta 2. This is for parallel flow and this one for contour flow. Now overall heat transfer coefficient. Overall heat transfer coefficient is designated with the letter U. Overall heat transfer coefficient is designated with the letter U. The formula is 1 by U is equal to 1 by Hi plus 1 by HO. 1 by Hi plus 1 by HO. So Q is equal to UA into theta m, and area can be write as pi dl. Area can be write as pi dl. The thing is that in every problem you have to draw the diagram. The problem is related to parallel flow or the problem is related to contour flow. Depending upon that, you have to draw the diagram. So this diagram is for parallel flow. As you can see here, hot fluid is going from left to right and cool fluid is surrounded with that, and it is also going from left to right. Hot fluid also going from left to right and cool fluid is also going from left to right. Th1 is stand for hot fluid entry. Th2 is stand for hot fluid exit. Th2, this one is known as Th2, hot fluid exit, hot fluid entry, hot fluid exit, and Tc1 stand for cool fluid entry and Tc2 stand for cool fluid exit. After that, this one for contour flow. What is given here? Contour flow. In contour flow, Th1 is starting from left to right and Tc1 is starting from right to left. Okay, now here the temperature of a hot fluid will be slow down, okay, and here the temperature of a cool fluid will be increased. As you can see in this diagram, the hot fluid is going from left to right and the cool fluid is going from right to left, but in opposite direction. As you can see the parallel flow and here you can see the contour flow. Okay, now parallel flow the direction will be same, in contour flow the direction is different. Okay, now direction. So you have to remember this formula if you want to solve any type of problem. What is the first formula? Q is equal to MH CpH Th1 minus Th2. Then heat loss by the hot body is equal to heat gain by the cool body. MH CpH Th1 minus Th2 is equal to MC CpC Tc2 minus Tc1. LMTD for parallel flow, LMTD for contour flow, then overall heat exchanger, then Q, then area, then parallel flow, then contour flow, then parallel flow, then contour flow. Like this you have to find out if any problems is given. We solve some problem based upon that. Now as you can see, like this problem will be given in examination. So here what is given, the flow rate of hot and cool water steam running through a parallel flow heat exchanger R. So here mass is given, mass is equal to how much, 0.2 kg per second, and another mass is given 0.5 kg per second. First mass is for hot fluid and the second mass for cool fluid. First mass for hot fluid and second mass for cool fluid respectively. The inlet temperature of the hot and cool sides are, inlet temperature means, see here, inlet is known as TH1 and TC1. So this one you can take as TH1 and this one you can take as TC1, TH1 and TC1 respectively. The exit temperature of the hot, exit temperature it is known as exit temperature TH2, hot is given now. So you have to take as the TH2. If the individual heat transfer coefficient on the both side, individual heat transfer means HI and HO will be given. What is given? HI. HI is equal to how much? 650 watt per meter square degree centigrade. Calculate the area of the heat exchanger. What you have to find out? Area of the heat exchanger. What you have to find out? Area of the heat exchanger. So what you have to do? First you have to draw the diagram for parallel flow. You have to identify given which type of flow is there, in the given which type of flow is there. So here first masses are given. What is given? Masses are given, masses for the hot flow and cold flow. So here mH is given. If you are going for the solution, first one what is given? mH. mH value is equal to how much? 0.2 kg per second, and mc is also given. mc is equal to how much? 0.5 kg per second. This is mass of hot fluid and this one is the mass of cool fluid. After that what is given? The inlet temperature of the hot and cool fluid. Inlet temperature of the hot fluid is equal to how much it is given? 75 degrees centigrade, and inlet temperature of the cool fluid is equal to how much is given? 20 degrees centigrade. First one is the 75 degrees centigrade, second one is the 20 degrees centigrade. And exit temperature of the hot fluid is given. Exit temperature of the hot fluid, how much it is given? Exit temperature of the hot fluid, how much it is given? 45 degree centigrade. The exit temperature of the hot fluid is 45 degrees centigrade. If the individual heat transfer coefficient, that is 1 by HI, 1 by HI is equal to how much? 650 watt per meter square degree centigrade, and 1 by HO is equal to how much? 650 watt per meter square degree centigrade. Now calculate the area. He is asking to find out the area. He is asking to find out the area. For finding the area, what you have to do? You have to follow that pattern. Whatever the pattern I given, that one you have to follow, and you have to identify whether the given one is the parallel flow or contour flow. In given question, the given one is the parallel flow. Which type of flow it is? Parallel flow. Mostly two types of flow is there in that. So this one is the parallel flow. So here I given the formula. First formula I given. What is the first formula? Q is equal to mH CPH TH1 minus TH2. So first you have to write that one. Q is equal to mH CPH TH1 minus TH2. So here you have to write Q is equal to, what is the formula? mH, this is CPH, next one is TH1 minus TH2. This is the formula for heat transfer. You know the value of mass. How much mass value is given? 0.2. And how much you have to take this one? 4187. How much you have to take? CPH value is constant, 4187. Then TH1 value. TH1 value is equal to how much? 75. And TH2 value is equal to how much? 45. If you solve this one, you will get like this: 25122 joules per second. How much it is? Joules per second. Here you got the value of Q. After getting the value of Q, next you have to substitute the second formula. What is the second formula? As you can see here, heat lost by the hot body is equal to heat gained by the cool body. So here you have to write heat lost by the hot body, heat lost by the, so I will write here First I have to write the formula. Heat loss by hot body is equal to heat gain by cool body. Heat loss by the hot body is equal to heat gain by the cool body. So, what is the formula? mH CpH into TH1 minus TH2 is equal to MC CpC Tc2 minus Tc1, Tc2 minus Tc1. Here what you have to do, you have to substitute the values. You know very well mH value is equal to how much? 0.2, and CpH value is 1487 into TH1 value, how much it is? 75, and TH2 value is equal to how much? 42, and MC value is given, how much it is? 0.5, then Cp2 4187, that is constant value, then Tc2, you don't know the value of Tc2, Tc1 is equal to how much? So, if you solve this one, okay, now if you solve this one with the help of calci, you will get Tc2 is equal to how much? 32 degrees centigrade. How much you will get? 32 degrees centigrade, 32 degree centigrade. So, first what you find out? Heat transfer. Then what you find out? Heat loss by the hot fluid is equal to heat gain by the cool fluid. Heat loss by the hot fluid is equal to heat gain by the cool fluid. After that, you have to write LMTD for parallel flow, PARALLEL, parallel flow, because in question it is clearly mentioned that the given one is the parallel flow. So, here you write down the formula for theta m. What is the formula? Theta 1 minus theta 2 by in of theta 1 by this is theta 2. So, here theta 1 can be write as Th1 minus Tc1, and theta 2 can be write as Th2 minus Tc2 by in of, here can be write as Th1 minus Tc1 by, and here you can write as Th2 minus Tc2. Okay. After that, you have to substitute the value. After writing the formula, you have to substitute the value. As you know, Th1 value, how much you got? Th1 value in your question it is given, how much it is? 75, and Tc1 value, how much it is? 20, minus Th2 value, is equal to how much? 45, minus Tc2 value, just now you got how much it is? 32, by, then in of this is 75 minus 20 by, then next one is 45 minus 32. Now, with the help of calci, if you solve this one, you will get the theta m. How much you will get? 29.12 degree centigrade, 29.12 degree centigrade. Here you got the theta m. After getting the theta m, you have to draw the diagram for parallel flow and diagram for parallel flow. As you can see that inside this is one line, this is one, and this one is one, and this one is one. As you can see that inside is which fluid is flowing? Hot fluid, hot water, and surrounded with cool water. This one is known as cool water, and this one is also known as cool water. Okay, not cool water. So, both the direction are in from left to right. Both the direction are in from left to right. After that, you have to draw this diagram. In this diagram, Th1, this is Th1, and this one is the Th1, and this one is the Th2, this is Tc1, this one is known as Tc2, Th1, Th2, Tc1, Tc2, and here this diagram, this one is known as area, this one is known as area or length, and this one is known as temperature, this one is known as temperature, this one is known as area or length, After that, overall heat transfer coefficient, after that which formula you have to use? Overall heat transfer coefficient, coefficient, Overall heat transfer coefficient formula is like this is there, 1 by U is equal to 1 by Hi plus 1 by HO, 1 by Hi plus 1 by HO. So, here 1 by U is equal to, you know the value of 1 by Hi, how much it is? 650, and how much it is? 650. If you solve this with the help of calci, here you will get the value of U 325 watt per meter square degree centigrade. What is that? Watt per meter square degree centigrade. After getting this value, the final formula you have to use. What is the final formula? Q is equal to UA into theta m. In this formula, you have to separate the area. Area is equal to Q by U into theta m. Q value is equal to how much? Q value already you got in starting, that is how much? 2 5 1 2 2 by U value is equal to how much? 3 2 5. Then theta m value is equal to how much? 29.12. If you solve this one, you will get the area. Area is equal to somewhat 2.66 meter square. How much area? 2.66 meter square. Like this you can find out whenever the parallel problems are given. Okay, na? Contour flow problems are area is equal to 2.68 mm square. So, this problem is based upon the heat exchanger for parallel flow, problems based upon the heat exchanger for parallel flow, and some more problems we will see for contour flow and as well as for the parallel flow.